À 8h07. Tu l'as pas vu? I will be there for the QA session, ça veut dire quoi? Ça? Ouais, je pense que c'est ça. Mais je pense qu'il était connecté, non?
Moi? Vous parlez de moi?
Ouais, Philippe? You.
Oui.
Okay. Do you present in live your presentation from your PC or we?
No, normally it's supposed to be a video.
Okay,
Then I
that's
join
right.
for the Q&A session.
That was the question. So we have the video, and you will only answer to the questions. Okay?
Yep.
Okay. Thank you. C'est bon? Okay. So I suggest now to begin the session. So we have, as we said, the 10 minutes French delayed due to the early time for the French. So we begin now the session. So I'm very happy to chair the session with Tina that you see on the screen now together, and we do that. And if you're ready, I suggest now to begin as soon as possible. So thank you very much. Welcome and have a good time in the session.
Good morning, everyone. I know it's very early for French people, 9 o'clock. No, but Lyon City is very nice, so I understand why you're spending some time in the streets. Sorry. So I'm very glad this morning to present to you our feedback on our road beam deployment on highways. I am Denis Leroux. I am a technical head of beam department at CETEC International. And CETEC, oh, come on. So, first of all, who is CETEC and what are we doing? CETEC is an engineering company based in France, but we operate everywhere in the world, abroad. And our main aspect is that we always want to have a value engineering and have a new inventive way of doing things. We operate in transport and infrastructure, so like bridge, highways, tunnels, metro, airports, so on, and also in building and urban and land development. So what's our strategy in BIM? Our strategy is to focus on the benefits of the project. This is a feedback. We started not like this. We want to do BIM because we want to do BIM with a lot of things. You will see that later. But with the experience, we really see that you have to focus on what kind of benefits do you want from the BIM on a specific project, and you will see that sometimes very little things can do a lot. So we have to focus on different aspects or different topics in collaboration, in interaction between people, in cycle life, in operating and maintenance, and so on. What's on motorway from 2015? First of all, come on. There is something wrong with the screen. should be green at the middle rows. Can you change that? So just for foreigner people, a quick introduction on how it's working in France. It's not the same everywhere. In France, we have a law, which is the law MOP, which says that, okay, I'll do like this. Here, the client will begin a new project, okay? And then we'll have one or several design offices doing the prelim design, then the scheme design, okay? That's where we will do BIM models. But then we will have the contractor, and the contractor will have to redo the BIM model. So we have a big disruption, big stop into the process, into the BIM process. This is very painful in many ways for BIM, okay? But that's it, that's how it works. So we have BIM model for designer and BIM model for contractors, and they are not the same, and we cannot give them the actual BIM model. They have to redo. Oh, come on. Okay, computer is down. Oh, thank you very much. Nice one. But wrong screen. No. Sorry. So yes, basically we have a big stop into the BIM model. So we have to redo. It costs a lot of time and a lot of money, of course. First project I will talk is one of the first projects we did with a BIM process. It's from 2010 to 2015 to 2020. The employer request was, I just want BIM on my project. So that was very vague and we didn't know where to do. So our strategy was to use BIM for collaboration and to improve our team knowledge on BIM because we were just beginners, we didn't know where to do. And we modeled almost everything at every stage, like bridges, roads, earthworks, but also landscape and trees and so on. And we wanted to test the BIM model for virtual reality. So the feedback on that is that we didn't, at the time, we didn't have IFC software. So the software were not able to produce IFC. We spent a lot of time to translate our model, CAD model to BIM model, and a lot of 2D software didn't produce actual 3D. So like for traffic signs, we had to develop specific software to get the traffic sign information to do 3D models from that. That was very painful. And for the model, we need to model as well stuff that we didn't use to model at different stages of the road. Let's say if you do a road and you don't put the road markings, you won't be able to see how many lanes do you have on the road if you are just looking at the actual BIM model. If you don't have lane to say, okay, I have a different lane, or if I have a crossing or so on. It's very important to do this stuff. Now it's common, but at the time we didn't think that we had to do the road markings. And a little word on virtual reality. It's very good for helping people that are not technical people to get into the model, but it costs a lot, and it's you know, the cost is not, on my point of view, is not the value that you get back. And then the client says, okay, that's very nice, we have a BIM model now. I would like to use that model for operating and maintenance. So we asked the contractor to do BIM model during the construction phases. And the client wanted as well to use those BIM model into GIS software and GIS database. At the time, and still right now, the problem is that contractors may not all be ready to produce IFC or to produce model with enough information or with the level of all the information that are required by the client. And we did a big job as well with the client to be sure that all the information we put on the IFC models, the names of information, will be the exact same names that we will have on the GIS database. That was a quite good job for them and for us. So what the process we kept is that every single contractor will produce an IFC. Let's say they will just have geometry in the IFC. Then they will produce Excel files saying that at such project or such part of the project, you have such or such information. Then all those information will be processed with the IFME, and IFME will be based on our asset database. That was an actual access file. So in the access file, we had all the all the information we had to tag into the IFC model. We get the Excel file, and we check that the Excel file is compliant with the database, and then we push the data into the IFC. And at the time we do the push to the IFC, we extract some quantities, volume, and so on to a GIS and quantity report database that allows us to connect Power BI software. And then our client gets plenty of IFC, but all the IFC have the same names for the attributes, same codification, and they can do requests on all their IFC files. So as you understand, the feedback is that the full IFC process, as opposed to the non-IFC process, is very handy because everyone can produce now IFC. We can push extra data on the IFC, and the transfer from IFC to GIS is quite difficult if you want just 3D IFC to 2D GIS, because at some point, if you use a ditch, for instance, when you model a ditch and you want to get the invert level of the ditch, this invert level you may not be able to retrieve it in GIS. It really depends on the way of your software that you use to produce the IFC of the ditch, code the geometry of the IFC. So if you have a BREP, basically you won't be able to get the invert level. And the benefits also is of the IFC is that by the time we started in 2015, and this job was done later on, and by the time plenty of new community and new operators will had to produce library to allow us to manipulate IFC in codes and to automate processes. Another project is with Vinci Autoroute in 2015, and it's still ongoing. The project is on construction right now. This is a design process, and our clients give us some specifications. So he wants BIM for design phases, but not specifically for construction phases. And the strategy was to have a team working and meeting every week around the BIM model, and also to involve non-BIM user into the BIM strategy. And by involving non-BIM user and to make them think, what can the BIM bring to my discipline? Let's say in road pavement, we had a big issue. Let's say the motorway is a two ways motorway, so one up, one down. The location of the project is in a turn, and the two sides of the motorway have a difference of level, okay? And the construction of the phasing of all the material pouring for that project was very difficult because we had to bypass the traffic for maintenance of on the main bridge. So we had to produce a temporary bridge, make all the traffic going there, and go back then to the original position. So all the all the pavement strategy and phases was designed with BIM. So that was very good. Another project is the A57 in Toulon with Vinci autoroute again. The clients on that project provide CDA. This is a big step for us because usually we had to manage and to pay for the CDE. But there, as the client provide the CDE, both designer and contractor were able to collaborate together. Our strategy there was to bring BIM on site, and this kind of platform CDE is a big asset for that. So everyone can go there, look at the BIM model, add comments, and so on. And we tried also virtual reality on site. This is quite good to be sure that every part of the project is laid at the correct location. And we did some control that was very interesting on that. So the feedback is that for detailed design, the use of BIM was very handful for us because large project, many networks to integrate. And for the next step is for as-built model. As-built model has to be done in real time because if not, the data is lost. So the big issue there is to be sure that you will be able to collect data from site in nearly real time and to get the data from site to be able to control your BIM model with the land survey of the existing condition on site. Last thing, virtual reality is good at start, but you really need someone that is an expert on site to launch that about 1 or 2 months. What's next? In all the phases of the project, we see that site data is something very important. So our strategy is to try to think how can we process easier and quicker site data. To do that, CETEC launched an R&D project with a new startup company. And this project is based on two knowledge. The startup has the knowledge of treatment of cloud points. Okay, we have the knowledge of engineering, of what we can do with the cloud points and what we want to extract from the cloud points. So the project is to have a platform with fully automated process. So this is a test. This is our cloud points. We bought it. We just drop the cloud point in it, press run, and that the process will do the vectorization of every traffic line. You will have a report of what kind of lane do you have, what's the width of the lane, what's the crossfall of the lane, what's the width of the platform. And also you will get the land XML of the alignment. And this is something very new and something very interesting for us because we get the MMS survey, put that in the machine, and let's say 2 minutes later, we will have everything to start our new design. And this is a lot of time, a gain of time and a gain of accuracy as well, because we are sure that if there is a mistake somewhere It's not because the guy who did the digitalization was a bit tired and clicked on the right instead of the left. This is something that we'll have systematically because it's an algorithm. So if there is a problem there, we will have the problem everywhere in the same location. We have to correct that and to run it again. So shortly, we will provide this new opportunity for who wants to use it. And this is, I hope, a good strategy. Thank you very much for listening. If you have any question, I'll be pleased to answer it.
So thank you for the presentation. So if we have some questions from the room and from Umbrella, so Tina, if you have some questions from Umbrella, say to us and ask.
There is no question.
No question at all? So
No,
is there any
no.
question or comments in the rooms?
That means that the presentation was accurate enough.
No comments? No questions?
I have one question actually of my own, if I may ask.
Okay, you can ask.
Okay, you mentioned the CDE environment in one example, that it was something that client was providing you. What kind of process you had for the documents or information, how to use that environment?
So this environment is used to drop all the IFC files of the project. And from one side, we have a process to control the BIM model. Actually, when you see on the first project, which was the A36, we developed a software that was able to control the model, not the clashes because we have software doing that, but control all the information into the model. So that process is done with our software on our side. And at this time, we inject extra data on the IFC. We didn't use a BCF, but we use IFC. So we add extra data on that IFC that allows us to see or to highlight into the CDE according to a specific property set all the objects that have a default on them. So on the CDE, we can use that and exchange with our team who is doing the design control and with the team of the contractor who is doing the modeling and the construction. I hope this answers your question, Tina. Thank you.
Yes, thank you. You did.
Yeah, but okay. No questions at all? Everything is perfect for you? Understand all?
Now
If any question, we are...
questions in Prela.
Ah, okay.
If I may ask these, or do we have time still left?
So, okay.
Yes, so there is a question in Prela that will the data from the as-built model being used as a basis for asset management? And are there some standards for the data interface to asset management?
Standard for the, sorry?
Kind of that, was there, will the data from the as-built model, will it be used as a basis for the asset management purpose?
Yes, the models, we work again on that asset management, and all the model on all the project we shows you will be used for asset management. So that's why it's very important for us to integrate data into the models. And most of all, we also did a test, which was not quite efficient on the IFC format, which was to link every single part of the BIM model in IFC to the relevant drawings where the object is represented. So in the IFC, there is some specific object that allows you to attach documentation to a certain part of object. And that was not working at all, so I hope new version of IFC will do that, or if not, I hope we can do a test for a next version, maybe version 5 of IFC. But yes, everything will be used for asset management.
And then there was a question about that, what software you used for road design.
Plenty. In road design, we have many different disciplines. Like you have ecological system, you have a drainage system, you have road pavement, you have underground, you have plenty of stuff, you have traffic signs, and every single discipline is using a specific software. And according to the topology of the infrastructure, you may use one software or another for the same discipline. So for the E36, we used Civil 3D for the geometry and the roads, and Reno 3D for the bridges. For PI661, we use Revit for the bridge, and Civil 3D for the roads. And for A65, we used Mansura, which is a French software, very good actually. And I used to work there, so Mansura for the roads, and for the drainage system, and for the traffic sign, we use our own software. So plenty of softwares.
And then if there might be still a few minutes left time for this session, or this presentation, so a few more questions. That what version of IFC did you use?
The one that was available in the softwares,
So
unfortunately. So that was 2x3. So we didn't have the ability to push alignment information into the model. But I hope that for the new projects that are still on construction, for the operating and maintenance models, we will be able to use 4.1 or maybe 4.3 if the release of our different software integrates the IFC versions.
And then a couple of questions related to data semantic, kind of that did you have some kind of beam execution plan or some document, or how did you define actually the information needed? So that in IFC there is a lot of information that it's not needed, but the minimum requirements, the information itself.
So that's the info, how we define the information needed. We didn't get any information requirement from the employers, from the client. So we actually, as I told you at the start of the presentation, we always see with the client what's the benefits and what they want into the model. So we did some exchange session with the operating and maintenance staff to see what kind of information they need into the models. So we did the database of what kind of information we'll have to put on the IFC, and from that, and in exchange with the client and with our technical team, we did that data dictionary, and we applied that on those 3 projects.
Okay, Totina, the very last one now.
Yes, there is only one question.
Only
I
one,
promise.
the last one.
Only one
Please.
in
Okay.
Prela. So kind of that, what software did you use to generate the combination models? Because there was many different software for different disciplines. So what was the name of the software for combination model?
Basically, we use the IFC. It's not specific the software; it's the format. So
yeah,
since you use the IFC, you don't really care of what kind of coordination software you're using. So that's the main point.
But in the CD, maybe the CDE
and the
environment.
CD as well.
So.
And that's the main point, and that's the main feedback, that on infrastructure project, as we have plenty of different software with closed formats, we really have to have a strong IFC format that allows us to support IFC infrastructure object. And that's also what we want to do with our R&D project. So right now we are doing a GIS information, a standard GIS information on land XML, because that was the first try. But surely we will soon go to IFC, and with the new version of IFC, I'm quite confident in the ability to quickly prepare a BIM model quickly that will allow everyone to implement digital twin, because as you know, existing condition is the first step of digital twin. Digital twin on new project is good, okay, but for infrastructure, digital twin is mainly existing project, existing condition, and that's the big challenge for the next years, to acquire existing condition and to quickly move to BIM model from that existing conditions. Thank you very much.
Okay, thank you very much to all for the questions. So I suggest now to switch to the next presentation. So we'll be online. So Philippe, you are connected, and we will have the video, and you will be present for discuss. So I suggest all the attendees to ask questions from Bella during the presentation. So not for Tina, it will be more easier to transmit to us during the end of the presentation. So when ready, it's okay. So we can. Tu balances. Okay.
Welcome to this presentation about the Hampton Road Bridge Tunnel project overcoming interoperability. Let's start directly with the cat's opinion. So this is my cat, this is Lima. It's a very cute cat, and she's a very good listener. When I come back from work, I like to share my problem with her, and she always listens to me. So I often ask Lima, what do you think about BIM in infrastructure? And she always answers me like this, with this very skeptical face. And this presentation is to understand why Lima's face is skeptical about BIM infrastructure, considering the following points: the lack of interoperability between softwares, the software's limitation, the lack of standards, and the employer's requirements. We are also going to see what we could expect in the future to happen. So again, hello everyone, I'm Philippe Testa, I'm the speaker. I'm a BIM manager from Vinci Construction Grand Projet. And I've been the BIM manager for Hampton Road project from 2020 to August 2021. My hobbies are board games, and I love to read a good manga. So what we're going to see today, it's first the project's BIM context, the software's limitation will lead us to interoperability and how we overcome them into this project, and then we'll continue with what the industry needs. First, a little context. So the project happens in the east of the United States, in the state of Virginia, and you can see on the Northampton and in the south, Norfolk. So there are two artificial islands existing and bridges and tunnels connecting the two lands together. So let's see that maybe with images. So you have here going from Hampton to Norfolk, the existing roadway and the existing bridges. So on the North Trestle, we're going to demolish the existing bridges, and we're going to build new ones and expand the roadway and doubling the lanes that exist already. Going forward, we arrive at the two existing tunnels with the two artificial islands that were built in the last century. We're going to expand these two artificial islands. The North Island is expanding a lot, and the South Island a little more. On site, the North Island expansion is actually almost over, and we're going to build two tunnels under the water. So more lanes for the project to avoid traffic jams. On the South Trestle, from a top view, we see the existing bridges, and we also see the beginning of the Willoughby Bay, which has also a bridge. And we're going to demolish the existing South Trestles to build new ones, with doubling again the lanes. We're going to expand the existing roadway, and we're going to rehabilitate the Willoughby Bridge. Arriving to Norfolk, we have the existing roadway, and again, doubling all lanes for the roadway. And of course, this is all to avoid the traffic jam, because people who lives in Hampton works in Norfolk, people who lives in Norfolk, of course, works in Hampton, and everyone is blocked every morning and evening to go to their work and to go back home. Now, what are the BIM requirements of this project? So it is to provide 3 models of the proposed conditions, also of the existing infrastructure, and from these models to build 4D models for the client and for all stakeholders around this project. We have to provide at the end geometric as-built models and integrate within the GIS software of the client. What's important to notice, and this is an important point, is that 2D drawings do not need to be extracted from 3D models, and the 4D is mainly for communication purposes in the client's point of view, to share information about the project with all stakeholders. Also, one point, the clients want all models and all deliverables to be within the Bentley environment and ask for the DGN format, which will lead to other topics. In terms of organization, so we're 3 companies doing the construction joint venture. There is Vinci, Dragados, and Flatiron, and we're in blue in this graphic. There is also a design joint venture in orange here, which is Mott MacDonald and HDR. So we have a BIM team, which is in the center of this graphic, that really works every day with the construction team and the scheduling team to create the 4D models, which can be 4D models for means and methods, or 4D models for scheduling. We are then the BIM team is the main point of contact for the DGV BIM manager, and who provides the 3D models of the proposed conditions, and the BIM team defines the requirements for these 3D models. The BIM team is also the point of contact of the employer's BIM manager, who set up the first requirements of the project. So now in terms of the main software's architecture within the project, so in terms of modeling software for the permanent works, so they're created by the designers within the Bentley environment, and they are using the V8i solutions, which is a requirement from the client, with OpenBridge Model SF3, Geopack, ICOSIM Building Designer, and we also started to use Connect versions of the Bentley products. In terms of the constructor side, we are more used to use AutoS products, so for temporary works and survey, AutoS Revit and AutoS Civil 3D is used. For the 4D production, in terms of scheduling, we use Primavera that we import into Synchro Pro, and Synchro Pro is the main software to create the 4D models. We have then a bunch of web viewers to share the information. FieldWire is used to share the 2D drawings, which are approved for construction directly to site people. We share the 4D animations within Microsoft Stream, so in a cloud environment, and we also share the 3D models with the web viewer vector that we will see more details later on in the presentation. Now let's jump into the topics of the presentation. First, the software's limitations that will define the context why we are facing also such trouble with the interoperability between the softwares. So one main software's limitation is that US Survey Fit is usually not supported by the software. You may not know what US Survey Fit is. It's like the international fit, but it's a bit different, as you can see on the screen. If you take a 2 million feet road, you will have a difference of 2 feet, so it's really minor. But in the case of infrastructure projects, you can have problems like this. This is a screenshot of the same model imported, one in US Survey Fit and one in international fit. You can see directly the problem that the coordinates are not the same into an infrastructure project like this. So we really need to have this, to use this US Survey Fit to have the correct geolocation of georeferencing of the elements, and also because it's a client's requirement. And all the infrastructure softwares like AutoS Civil 3D, OpenRoads, Geopack, Vector can manage the US Survey Fit. They're really linear softwares, but all the BIM softwares that are usually used by companies into a building environment or a vertical infrastructure environment do not handle the international fit, and it can have huge consequences. So how do we overcome that? So we have first process to handle this topic of unit. So this example on the screen is within the Bentley environment. So if you have experience with those softwares, you know that there are a lot of files which are DGNs, because, for example, if you take building, you can have one DGN per discipline and then per levels. So you already have a lot of working files. So you put them into a first container. So all these working files, we're going to put them into an international fit container, and that we need to convert into a US Survey fit container. So the second one, the coordination models on the screen. And then for that, the theory is that we extract all the plans, section, elevations to create the sheets of the project in US Survey fit. However, surprise, it doesn't work. The software cannot handle really well the scaling factor, and so we faced a lot of display issues creating the drawings of the project. So we had to change the process a little bit, and we had to create the drawings directly from the international fit container, which is obviously not ideal. And then we control the project points and make sure they are correct directly within the sheet, which are then in US Survey Fit. And we have another container for the federated model in US Survey Fit for coordination. But this is not okay, this is not perfect, and this is not how it should work. Now, another software's limitation is that softwares are not all capable of handling georeferencing. Most of them are handling geolocation with local coordinates. It's the case, for example, for SynchroPro here. If you take a model that's georeferenced, you will have trouble navigating into it. You will have display issues, and here is just a small example of how annoying it can be with the difficulty to select elements, to have the screen really shaking when you are trying to navigate around. And so you have to make sure that you bring all the models closer to the 0, 0, 0. There are many other software limitations, and I will cover some more here, but we don't have time to cover in detail them all. So the tunnels, first one, the tunnels are modeled with generative components, which is the equivalent of Dynamo 48, but for Bentley products. But the models are not georeferenced. Also with generative components, the VLI products of Bentley are not powerful enough to generate the tunnels we had, so we had to pass with the Connect version, which was outside the contract. Also in SynchroPro, nested files, so if you export a container with a lot of reference files, Synchro has trouble sometimes handling these files when synchronizing. So that was an issue too, and you can see, I'm going to illustrate what kind of problems it creates. So we have here on the left an image of a bridge again, where the elements are not selected, and when you select the element, you can see that the element is shifted, which is of course not okay. And you can imagine that it's not the only behavior that you have also. There are many others that are very weird. And another one that was very annoying is that the it's not possible to apply the scaling factor within VLI products that easily, because there were just too much numbers after the dot. So we had to open the Connect version of the Bentley product, apply the scale factor, and then go back to the VLI version to really have the models in the correct software with the correct unit. And that leads to interoperability. We saw a lot of software limitation, and now we have to make sure that these models are correctly into the federated model, and that everyone can use them, the constructor and the designer, whatever is the original software. So it's really to overcome interoperability to answer the client's requirements once the model is into a DGN format, and overcome the interoperability to support operational teams who wants to use the models for temporary works and to create sequences and so on. So my recommendation is that at the beginning of a project, you start doing a big Excel file and you do a color code. You look at the native model to its geometry and its data. You put it in the second software, you see how it arrives, and you try to define the best format to achieve this. And so with no surprise, on our own Excel file, there is a lot of red and black cells. For example, if I take this bridge and I put it directly into SynchroPro, we have not the same geometry at all. For the tunnels, we had a lot of trouble as well. So you, the funny images here, you can see that the tunnel is not correctly at all. And I didn't even start talking about the geometry. So for this presentation, we're going to focus on one complex interoperability process that we put in place, which is the Bentley Products 2 Synchro Pro. So for the permanent works, we're going to consider the OpenBridge, Geopack, and Ecosystem Building Designer to Synchro Pro, considering all the software limitations we just saw. So at the beginning, you need a model, so you have to develop your models, and then you have to export all the working files, which are a lot, to IDGN. IDGN is a closed format from Bentley environment that allows you to see from a viewer, a Bentley viewer, the models with the correct geometry and the correct data. If you open only a DGN as a standalone, you won't have all the data attached to the objects because it is not into his Bentley environment. So that's why we asked the designer to export all the DGNs to IDGNs to the lowest breakdown structure. We create now a DGN container linking all the IDGNs, and we transfer all these references closer to the 000 because, of course, the models are georeference. So we need, because of the Synchro Pro limitation, we have to put them closer to 0, 0. We then have to scale the correct models, so the models that are coming from Ecosystem or Open Building Designer, because these softwares do not handle the US survey fit. And then we have to use the VIDI Synchro plugin to export to a Synchro format the best way possible. You may, if you're familiar with Synchro, you may say, but why are you not using the Connect plugin, which is a more recent one, so it's supposed to work better with the latest technology? Well, it actually doesn't work properly, at least in our case, with the software of this project, so we had to stay with the old technology, which is not going to be supported by Bentley at the end of the year. But we managed to put them all into Synchro. But we had to develop similar interoperability processes for all the softwares we use on the project. So for example, Open Building to Revit, or Geopack to Revit as well, passing by Simul 3D, because we need to be able to use the models also in the federation models and also in the native modeling software to be able to work with the reference correctly. So this is not okay, and we can imagine how it should work. We already have a common standard format, which is already applied in several building projects, which is the IFC. So ideally, all software can export directly to IFC directly, and with a great geometry and exporting the correct data to the correct place. We can then suppose that we are able to import this format into the federation softwares that we use in our case here, Synchro Pro and Vector. But we need also all the native softwares to be able to read IFC because, again, people need to use their own tool to work because they are efficient with these tools, and they choose these tools for a reason because they fit their need, and to import the IFC correctly to see the project context, to be able to work with the latest design information. The goal is not to have to learn every software in the world, but to use a software that fits your design office or your construction operation task, and use them because you need it. Now let's talk about the level of information need. So there are standards in the industry, especially for the building environment. So we can look at the BIM forum or the NBS BIM toolkit. But when you look at infrastructure, you see that for tunnels, for example, they say to look at global definition, or they're not even defined in the case of the NBS BIM toolkit. So at the beginning of an infrastructure project, you have to develop your own level of information need tables for the project. So that's what we did, and you need to make them really clear so there is no doubt on what BIM object needs to be delivered, what are supposed to be their 3D representation, what is the modeling scope, what are the data that is required for each object, and when they're due. Consider also that in infrastructure industry, everyone is not mature at the same level in terms of BIM, and having a really clear level of information table helps everyone in the project to understand what they can expect for different phases of the project to find into the BIM models. So what does the industry need? I think we already partially answered. We need a common format, an IFC format, and that's mature for infrastructure that is currently being developed. We need standards for infrastructure that makes sure that everyone can deliver the BIM models with the correct objects and the correct information. We need the owners to not close the environment and to have an open environment so everyone can work with their own tools to deliver their best work. We have, for example, the mine. We have to participate into the group of work like mine to develop these elements. But most of it, we also need something else. We need that editors need to work together. So I know they're competitors, but they should work together so we make sure we can use our softwares we prefer and that fits the best for need. There is not in the market one editor capable to produce all the softwares that fits your specific need. So you need to use the software you're the best at and be able to use the models that everyone can provide you with a common format. When all of this is achieved, I think I will be able to sleep like my cat and I will have no trouble going back home and she'll stop complaining. But now, let's see the final results of the project. It's time to awake your inner cat and look at close details of what we managed to achieve despite all this software's limitation. So here there is a 40 means and methods. We put the engines, and this is located in the south trestle, and you can see how the schedule and the 3 objects are linked. This helps construction teams and the client to understand how we're going to do the work, and we can do a reiteration process to understand what is going on the project. We also do 4D models at the schedule level to compare what is planned versus the real progress of the project. So here we have the North Island 4D model for the schedule, and we can see on the left the planned progress and on the right the actual progress. So you can see and compare the progress of it. I cut a bit the video so it would look more smooth in it. But now on site it's actually finished. And now we allowed all the teams to access the BIM models through a web viewer, which is reading all kind of GIS format and IFC as well in terms of 3D modeling. And it's really an infrastructure viewer, so it handles all kind of coordinate system and really apply them to the model. So we can see here all the project. It's also a really good viewer because it allows to select all the alignments of the project and to create directly a cross-section for the teams to review the project, which is rare into the industry today. So you have here, by clicking on 2 elements, the software calculating for a cross-section, and you can see what is supposed to be at the station you want. You can slide this cross-section to explore wherever you want on the project, and the software is going to calculate on the cloud again. The more object there is, the longer it is. And you can also navigate directly putting the stations of the project you have. And this is really useful, especially in a linear project like this one. So to conclude, I hope you have a good overview of what we did on the HRBT project. I put here, if you're more interested, a YouTube link that allows you to see the progress on site every month by drone. And happy conference.
Okay, Philippe, welcome. Thank you for the presentation. Very good presentation. Thank you to you. That's right. So now a few moments for questions from the room and from Brella. So on the screen, it's possible to have Tina also. And if there is question on the room, wake up. No? No questions? Tina, do you have questions from Brella?
There is no questions. Actually, one question from Prela is that what was the web viewer that was used?
So the web viewer that was used is called Vector. It's from a Finland company. And we really choose this viewer because it has this infrastructure capabilities to do cross-section and large data sections directly online. And this is very useful for the roadway teams to be able to navigate through the models with this feature. On the industry market, there are only 2 viewers doing this. It's the iTwin from Bentley, and I found this one as well. And that is the viewer used. That allows you also the things that viewers do, sections, like classical sections as well. And you can also classify according to the data and do filters and so on. And well, yes, we implemented that. They also developed some features for us because, for example, if you take the international fit and US survey fit problem, they developed a feature that allows directly in the viewer to scale the models that are not in the correct unit, because we were receiving sometimes models from suppliers that usually it's mechanical models, for example, and they don't handle US survey fit neither. And we were able to scale directly in the software. It's really a linear viewer again, because it takes all the coordinate system and they apply it to the models. So you cannot also change that directly in the viewer.
Thanks. And then I do have one question, of course. There was an example of documents level of information needed, and it looked quite detailed. And I assume that maybe 80 to 90, almost 100% of the information needed is quite same throughout the projects. So could that be something that we need to standardize next, at least some minimum requirements that every project will need?
So it really depends on the project actually, because the project is going to be separated in different phases, and for each phase there is going to be a level of information needed that may be different in terms of geometry and also in terms of data. So of course we capitalize inside Vinci about what we developed on the different projects, specifically in infrastructure, to know how to define those for the next projects, but the breakdown can be very different. And here we did that for the roadway discipline, the tunnel, the bridge, and landscape, and so on. But on this project, the level of information need was not that high for the project. So it's possible that for other projects, there may be more objects to define. But yeah, our goal inside also Vinci Construction Grand Projet, we have started a R&D project where we gather all this information and we propose for the main phases of a project that we defined as a basic design for tender and the first drawings, detailed design for the AFC drawing, and then the construction and as-built phase. For each of these phases, we propose a template of what objects, standard objects, can be proposed on the different projects for infrastructure, for bridges, roadway, tunnel. And this work has been done with the technical specialists of the technical offices and the projects. And so it's a living R&D project, and we try to improve it as much as we can, because it's a real topic, specifically for people that are not in the BIM environment, to understand what is in the BIM model and what they can expect. I think about, for example, quantity takeoff. This BIM use is oftenly sold like it's magic. So you have a BIM model and you press a button and you have all your quantities. And in practice, it's way more difficult than that, because you have really to have a clear defined model breakdown and specified all the information you want to have extracted. and the modeling software don't always automatically put the data you may expect as a technical person to be in the object. And so sometimes when a cost engineer goes see a beam coordinator and he says, can you extract me these quantities from the model? He extracts a rough extraction in an Excel sheet, and then the cost engineer goes back saying, I'm missing data and the breakdown is not correct. So having this table allows for each actor of the project to click to know, for example, for a pile of a bridge, okay, on this object, I will have these terms of detail in geometry, and I will have these dimensions and the material and so on, if it's defined for the phase of the project we are.
Okay.
I hope it answers.
Yeah, thank you. You did.
Right, thank you. So, if we have no questions in the room, Tina, a last one, maybe, if you have?
There is no questions in
No
Prela.
question.
Yeah.
Okay, so we will thank Philippe for the answers of the presentation, very good presentation. And we suggest to switch to the next one. And thank you a lot, Philippe. Thanks.
Have a good conference.
Thank you. So Justus, it's you? Justus, it's okay? You ready? Okay, if you're ready, you can switch the screen. And then it will begin. C'est bon? Dès qu'il est à l'écran, il commence. Okay, it's good. So the chair is yours.
Good morning for everyone. My name is Justus. I'm representing Ingus Engineering company as well the project team. I'd like to introduce our topic. It's sorry, you can hear me? Yeah, it's a long one, but the key message from it is you can reduce your risks in construction with virtual design and construction, shortly VDC. In this presentation, you will see a real case, less theory, more practical things, small things we incorporated in our work processes. Beside that, I'll try to highlight few project solutions, which, in my opinion, corresponds quite good to yesterday's opening session. I'm engineer, so not natural-born stage talker or presenter. Sorry for that. This morning I discovered that the presentation won't work as properly as I thought in this big screen, but I hope it will be okay. So to better understand our background, our experience, let me introduce our company. We are part of a company group, Ingus, which is together involved in design-build projects in Scandinavia and the local Lithuanian market. Ingus itself is focused on structural part of a building as a designer, manufacturer, and an assembler. We, Ingus Engineering, are structural design part of this process. Our team is more than 120 engineers, and we are one of the biggest structural engineering company from Baltic states. Today I will present one of our infrastructure projects. It's a railway bridge in main Lithuanian railway line. For now, main line, yeah. It's connecting capital city Vilnius to the Lithuanian port Klaipėda. The project provides design decisions for reconstruction of a bridge itself, and also for more than 1 kilometer length construction of railway line and reconstruction of communication and electronic networks. Here you can see how the existing bridge looks like. There is 2 decks. One is in use, the other one is not in use because of limitation of its bearing capacity. It's not sufficient for these days loading. One of the main challenges of this project is that the construction work is done nearby operating railway line, and the intensity of the trains is more than 50 trains per day. The railway line and bridge itself is a strategic object of regional importance. The bridge has identified as that from the beginning of its history. The guards shelters was built in both banks of the river, and the army people was on duty these days. Now bridge are secured in other ways. As well, the importance of a bridge shows aerophoto taken during World War II by German forces. The bridge itself has a quite long history behind it, and first bridge in this place was built in the beginning of the 20th century. In the upper view, you can see the first iteration of railway bridge and how it was damaged during World War I. Down there, first picture, you can see the rebuild of this bridge between World Wars, where rebuild was done with the same trusses, only one exploded support and one broken span was rebuilt with new steel structures. After Second World War, last 2 pictures you can see, in 1948, the new bridge truss was brought from Germany, and the bridge was rebuilt. This truss, this deck, was used until 1983. After that, a new system of the trusses was built. This presentation of the project will be about this reconstruction of this deck. The new steel structure is installed on existing supports. The main spans crossing the river is 75, side spans is 21 meter long. Total length over 207 meters. The new steel structure is designed on the ballast track on a concrete slab. Once the project will be implemented, trains can go through up to 160 kilometers per hour. The presentation is divided in parts corresponding to the project and parts and stages. All stages except construction stages is already done. Construction should be done in this autumn. You can indicate stage about what about I'm talking by colors in the right side of the slide. The client, LTG Infra, is like a Lithuanian railway company, decided to choose design build principle for purchasing this this project. This is not common in Lithuania, but in our opinion, it's the most efficient, effective way of purchasing the project. This allowed the project team to come together at very early stages. The contractor joint ventures Eurovia and LNK Industries, designer Inhus Engineering, the partners Sweco Lithuania and FIMA. Implementation of BIM was a novelty for the client as well for a contractor. This was first project in BIM for LTG Infra, and we are glad that Inhus Engineering experience in this area led the project team and the partners to believe in a high level of success with using BIM technology. In preparation for the tender, the contractor and designers prepared the concept for the construction of bridge and railway line. For verification of the concept, also the finite element calculation were made. And also was preliminary 3D model was made. From that model, we take material quantities, also smaller technical decisions were made. All this material were given for a contractor, and the contractor was able to rely on this material and to collect price for the tender with estimated lower risk of contingencies. The main achievement for a contractor and for a designer, I think, also was that they won the tender, and for a public client, this means most reasonable construction price. It's working. To assess the current situation, geodetic measures and scanning of the project area were made. 3D surfaces, 3D line, point cloud were made for the design. This led us to avoid costly and sometimes, I think in this case, dangerous measures in the field. Augmented reality was used to verify design solution at the preliminary design stage. The preliminary 3D model of the structures was transferred to the augmented reality environment with the help of site vision tools. This inspection allowed us timely adjust of solution that intersect with remaining structures. Also using augmented reality, the local society was introduced to the project. At the preliminary stage of design, environmental pollution researches and modeling was made to ensure to reduce the environmental impact of noise. Additional measures were made and also modeled in the model. Prior to the start of the design process, the BIM execution plan was developed and the requirements were agreed between project participants. The agreed rules made it easy to link parts of project to each other and check their compatibility. Actually, in Lithuania, there was no practice and norms how projects should be prepared in the BIM environment, especially in infrastructure part. Infrastructure projects, therefore, in preparing those documents, we mainly relied on foreign experience and in experience in building sector. Aside from BEP, the common data environment was created, and for the platform was chosen Trimble Connect. The CDE environment and the separation and empowerment of user groups led us to reduce the risk of information loss. In common data environment, also the relevant documents was attached to the BIM model. I will show it later how it was done. to ensure the use of relevant information and eliminating of risk of using of old information. Constant project checks, meetings with project team, contractor, element crash check, lowered the risk of mistakes in further stages and allow us to make changes in early stage of design. Our modest experience has shown that the full potential of BIM not be reached without constant supervision and strict process routines. The model of a bridge structure was prepared by Tekla Structure software. The level of detail was 400. This means that all inserts, reinforcement, connections, of steel structures, waterproofing, and other elements were modeled in precise geometry. For the manufacturing, the steel truss was modeled with a precamber of 120 millimeters. The precamber was set taking into account dead load, live load models, and manufacturing tolerances. Also, we need to consider the admissible ballast height range. Bridge deck calculation was made with finite element software Mida Civil. Connections were calculated with Idea Statica. All structural calculations were performed by estimating the installation of installation stages and simulating construction process. The railway part was designed using Autodesk Civil 3D software. Parametrical design tools were used to speed up the project delivery. All input information was used from 3D scan to create more accurate project surfaces. And this allows more precise estimation of groundworks. In Lithuania, there is no practice to design field utilities in BIM environment, but with this project, we decided that BIM should be implemented in all parts of the project. So the electronic and electric and communication network parts was modeled also in 3D with Revit software. This allowed to detect clashes in early stages with the existing and new structures. It was agreed with all project parts participants how to element parameters are named and what units of measurement they are presented. In this way, the information in the model was shown in the same way for all participants, and this eliminates misunderstandings for them. Tekla Structure software allows information to be automatically assigned to elements. Then BIM model is classified correctly by internal companies classification. This allows us easily. This function allows us easily to reclassificate to assign parameters what needed from a client, and not be strict in one parameter. And in order to meet customers' need, we can quickly reclassify the model. In this case, we use Uniclass 2015 for the unified classification system. I'm not familiar what the requirements of your countries, but in Lithuania, one of the main documents in financial point of view for a contractor and a client is the table with quantities of materials need. So all quantities of material from different parts in project were linked in BIM model and easily accessible in CDE. Also, CDE allows filtration using various attributes, and in this case by the material group which corresponds to the project table of quantities. The last revision documents is attached to the elements of a model, so the information is easily accessible to all project participants, and there is low risk that not relevant documentation will be used in manufacturing or construction. For project construction planning and management, the project execution schedule is linked to the BIM model using a Bexel Manager tool. Here you can see the schedule in dates. BIM linking process works automatically, so if there is a change in the model, there is no need of human work. It's lowering the risk of mistakes. In CDA, also possible to assign status of elements from manufacturer to assembled. That allows to visualize construction process. Also, the status of elements are linked to the project management tool, Bexel Manager. One of the key moments of a project was choosing construction technology. Selected technology led us to avoid unnecessary intervention in the river. Also, it leads to reduce, for contractor, reduce resources and materials because the existing structure were used instead of temporary new steel structures. The uniqueness of technology is that all the new trusses are launched together. So at one side, the new structure is assembled, at the other bank, old structure is dismantled. For this purpose, the connection joint between the new and old structures were made. All calculations were made in finite element program, and all added elements were modeled in Tekla software. And there is, I think, a good example how simple engineering solution and digital technology can lower the CO2 emission and can in the construction and can make a profit in your business. So the construction structure where you don't build the machine you don't use, and for the purpose to meet your clients' needs, don't emit CO2 and don't cost you money. So project digital model was used in manufacturing steel structures. Steel structures from Tekla software was imported to SolidWorks. In SolidWorks environment, the model was detailed to requirements of manufacturing, and detailed manufacturing drawings were made. During manufacturing process, some information were not used in BIM environment, and that complicated to manage the changes in the project. So the relevant information were used for manufacturing. This error shows that the importance of BIM usage in all project parts, all stages, especially in tight design-build schedules. The manufacturing error was identified in geometric inspection process. Here you can see down the picture, and also the partial assembly of neighbor sections of the truss was made in manufacturing place to ensure the proper assembly at the site. In order to ensure the quality of groundworks, the design surfaces were transferred to machines with automatic control. This assures the maximum compliance of project levels and coordinates, and lowers the risk of human error and minimizes the possibility of additional groundworks. For digital groundwork control, the drone scans were made regularly, and the results were compared with the BIM model. Additional control was done also in the structural part. Here you can see retaining wall scanning and comparing with the model. For the truss position control, geodetic measures were made after each launching stage. As well, partial scanning was made to see does manufacturing and construction tolerances corresponds to the requirements of the project. Yeah, and final question, does it make the difference for other construction parties? And let's hear from themselves.
Kas tai yra BIM? BIM tai yra Building Information Modeling. Galima sakyti statybų eigos atsekamumas virtualioje erdvėje, projektavimo atsekamumas virtualioje erdvėje. Tai yra tikslus dokumentacijos archivavimas. Naudojant BIM, projektuotojai gana tiksliai suprojektavo darbų kiekius, medžiagų ir gaminių kiekius. O rangovas galėjo pasirinkti pačią geriausią technologiją atlikti darbus. Mūsų bendroviai, akciniai bendroviai ETG Infra, tai buvo naujiena. Vykdydami Jonavos geležinkelio tilto rekonstrukcijos projektą, mes pirmą kartą susidūrėme šią technologiją, kuri iš tikrųjų mums padarė labai gerą įspūdį. Projektą mes galime, dar neatlikus visų darbų, pamatyti gyvai, kaip atrodys tiltas. Ateityje šį technologiją mums padės sutaupyti pinigų, resursų ir darbai bus atlikti kokybiškiau.
Dalyvavimas įgyvendinant projektą BIM aplinkoje iš tikrųjų leidžia visiems projekto dalyviams betarpiškai dalyvauti projekto įgyvendinimo ankstyvosios stadijos. Leidžia identifikuoti rizikas, kurios gali iškilti projekto gyvenimo eigoje nuo pat pradžios, nuo projekto sukūrimo iki jo vėlyviausios, tai yra iki gyvenimo pabaigos. Man kaip fizik inžinieriui tai tikrai padeda taupyti laiką tiek man, tiek kitiems projekto dalyviams, bendraujant tiek su užsakovu, tiek su rangovu, tiek su projektuotoju, tiek dokumentų lygmenyje, tiek sprendžiant projekto gyvenimo problemas. Be abejo, tai yra galimybė gauti patirtį ateičiai, kai BIM bus taikomas visuose Lietuvos geležinkelio įgyvendinamuose projektuose.
Tilto rekonstrukcijos konkursas buvo skelbiamas pagal geltoną FIDI knygą. Susibūrusi rangovų ir projektuotojų komanda atliko preliminarų modeliavimą ir pagal to preliminaraus projekto kiekius buvo laimėtas konkursas. Po konkurso laimėjimo, atliekant darbus pagal patikrintų darbų kiekius, buvo nustatoma iki 1–2% darbų kiekio netitikimo paklaida. Tokios paklaidos atliekant projektavimo klasikiniu būdu pasiekti būtų neįmanoma. Tilto montavimo metu buvo nuimamos geodezinės ataskaitos ir tie rezultatai buvo pateikiami projektuotojams. Projektuotojai atlikę sujungimo mazgo modeliavimą ir tilto stūmimo procesą, tas ataskaitas tikrindами leido выкдать tolimesnius монтажные дarbus.
Для того, чтобы сделать реконструкцию моста в Йонове наиболее эффективным способом, была выбрана довольно специфическая, в своем роде уникальная технология надвижки нового и стягивания старого пролетного строения. Еще до начала работ мы консультировались с ведущими европейскими компаниями по надвижке, однако они не смогли показать нам ни один схожий реализованный проект реконструкции. В итоге мы приняли решение разрабатывать технологию самостоятельно с участием наших коллег из компании Incus. На стадии разработки очень важно было сделать детальные обмеры старого моста, смоделировать его, смоделировать новый мост, их соединение. В итоге применение BIM облегчило и сам процесс проектирования, и процесс изготовления довольно сложной технологической оснастки и процесс надвижки строительства нового моста.
And the answer, I think, it definitely does the difference for all parts of the project. Once more, I want to thank you for all partners and for the courage and believe in us and BIM process. we believe it can be the new standard of project implementation in Lithuanian market. Here you can see my colleagues part of a design team. For deep and more detailed questions, please find them in the hall. And thank you for your attention.
Thank you very much for this presentation. So interesting. Tina, okay, you're here. The room also. So Tina, do you have question from Bella?
There is no questions from Prela. I'm not sure if there is any question from the audience of the room.
Okay, the audience? Okay, one question. Okay, that's good.
Thank you for the presentation. So you mentioned that you compared the BIM model to a point cloud each time you made the launching process. So so 2 questions about that. Which software solution did you use to view and to make the comparison? And my second question, was it a visual comparison or did you use an inspection tools to measure the deviations?
No, we didn't compare the point cloud. We compared the exact points measured in the geodetic technology. So, and it was measured by visual inspection. Yeah.
Okay. Okay for you. Another one? Or comments? Tina, something on Brella? Or in your head?
Nothing in Prela, but I have a question, of course. What about now the data that you have collected? Is it mandatory to transfer it to some client database for bridge maintenance, for example? Or?
In this case, as I said, we didn't have requirements from a client, so we will give all the data which will be collected in the common data environment to the client, and the client afterwards will choose what to do with this data. Yeah.
Another one? The last one, Tina?
Well, I can ask because I have one more question, of course, about the risk assessment process. In the beginning of the project, normally you identify the risks and then you figure out the activities that will mitigate the risk itself. So was there any kind of mention in the risk assessment process that actually we want to mitigate this risk by using the virtual reality or models?
I think the VDC only began then afterwards the award was given for tender, yeah, after we won the tender. In the preliminary stage, it was just engineering on the paper, and we didn't invest such a lot of money in this. Yeah.
Okay. So no question in the room. So thank you very much for this presentation. We will go now to the last of the session. Thank you. Thank you again. Thank you to all. Okay.
Thank you. How was the presentation slide? Where to find the presentation? Yes. Perfect. Show that. Okay, perfect. Thank you very much. Okay, so I hope I can speed up my presentation. We can then get to coffee break. I'm Rauno Heikkilä from University of Oulu, Finland, and topic today, development of road infrastructure, digital tools within Nordic construction education curriculum. That's the topic, and I need to use the arrows to move forward. Oh, that is not changing the slide due to some reason. I'm anyway working as a professor at the university and research area digital construction and mining operation. So far around 25 years had research program in environments for each student, and where we also utilize the BIM models in the VR user interface. They can see that using the guidance principle and utilize that way. That is also interesting application. Also, we can drive autonomously without human operator at all, that machine and based on BIM models. Like going to results of workshop, that was the first one, and we got some feedback, and everything was not working like without any problems, and we get some understanding that how to develop forward to education, and next aiming to the Jönköping second workshop. But the feedback from students was very positive. I think they mostly like that international collaboration with the foreign students together, and also that focus to train modeling really to the real project, and at that there was found to be very nice and interesting task, and the model sharing with Quadri code service worked very well, and nothing difficulties with NovaPoint modeling were found. Actually, they did not go to very detailed modeling levels, but tested mostly like road surfaces and road geometry modeling with the motorway alignment, and also some ramps additions to the main geometry. And they hope to get a more clearer a guidance to team working, and that we try to improve next in Jönköping workshop. As some conclusion words, also some crystallization of initial data and clarification of the modeling tasks. We hope to get better way to the students, and like a better schedule management guidance was hoped next to have how they can collaborate as a team, and maybe select the project manager themselves and set their own schedule to collaborate together and divide the different tasks in their team, that kind of things. And some technology and demonstration additions, still we are concerned next to having Jönköping. We are going to test remotely excavator driving from Sweden to Oulu, Finland, and let's see how that will work. And also have one site visit, if possible, some contractor to areas in Sweden, or introduce the real construction design and construction process examples, that kind of. But the students reported significantly improved skills after the 1 week workshop, and that was quite positive feedback for us teachers, and we are continuing that way. And the software worked very well, and no problems with them, and we still need the Trimble support in that developments. And I think the most interesting aim for us is that to have that first international course then in BIM-based road design, and to collaborate then continuously with these Nordic countries. And here's the last picture of our student and teachers group. For the next workshop, we will select Finland use the same student, but the other countries will select the new students, and that way we are continuing our improvements. Thank you very much for your attention.
Thank you. Thank you very much. So, Tina, the room. Is there any questions? No questions? Tina?
There is no question since Prela, but I can ask one
Well,
quick question, of course.
Okay, of course.
Yes, thanks. Will there be some publication after the research project is done? Or will you publish some report or where we can find maybe some recommendation for project teams, for example?
Yes, we will definitely have a project report after we have concluded our research project, but the schedule was it in the time in 2023 and September, something like that, and that is the time we will deliver a project report then.
Do you know if there are some other projects on the same themes all over in Europe, for maybe if there are some calls to answer some?
Actually, I do not know if there is somebody has that kind of information. We are very interested to know if something similar is under development or ongoing. Like what I know, this is the first real BIM-based with the model sharing features, that kind of educational at university level in Finland, and based on those Nordic countries universities, that is also the first one.
Okay, because
countries.
In your project, so there are only Nordic states, only Nordic university. Do you have link with university from the south of Europe? Or no?
No partners from Southern Europe, yeah.
And do you know why?
I do not know. Actually, we are thinking that the Nordic countries is ahead of the Southern Europe in at general level of the utilization of infra-BIM and anything. So I suppose that they do not have the similar courses yet.
Okay. Okay. No questions? Okay, good.
Thanks, Rauno. What about these new standards that are coming to this infra construction field? So how in future you are taking care of those, and is the goal in the future that these students would learn how to make the models which are suitable to machine control systems like right away?
That's a very good question, thank you, Manu. And what is really interesting that we have from Finland part suggested that why don't we utilize the standardized guidelines and information classification and open information transfer formats, and also add the connection to real construction automation issues. The other countries have not set that focus yet, and I hope that during the coming workshop we can develop and widen that education idea.
That's a good thing, because like you discussed together that there should be some more cooperation between in all over Europe, and soon we will have new standards which are like a common, so then we could have a great possibility to learn it, to make the design similar way all over the Europe or even all over the world.
Yes, and EU Horizon programs includes a unique, it's a European universal cooperation network to develop education at university levels, and it offers funding for that kind of, that is like a good example how we can start to educate teachers and renew the current education. Thank you.
Okay, thank you for the question. So I'm agree. So the formation, education, for young people, but also for old people, to go in this way with a numerical BIM is a very important challenge.
It
and
is, yeah.
not only in part of Europe, but in all Europe. And for the Europe, so I think there is something to manage between the links with university, high school, to develop education of people on these teams.
I agree that is very important to also consider the education development at different levels of education, and like we do have a continuous collaboration in all with the University of Applied Science. It's a little bit lower level than at our university level, and also with vocational college. We had done that over 5 years. But when we have the previous Erasmus Plus project, we had one university from Italy, and they included also high school education into InfraBIM education development. That was quite interesting finding for us to learn that countries are so different in education.
Okay, so there is something to do, and you have the lead. So you in Nordic states, you look to have the lead in this engineering. So help us to follow us. Okay.
Okay. Thank you very much.
Questions, comments? If not, I suggest to close the sessions. Thanks for the last presentation. Thank you very much. Thank you, Tina. Or last one, if you have. Umbrella, maybe, something?
There is nothing umbrella, and thanks for my side as well. It was a
Okay,
pleasure to be here.
okay. Thank you very much to you for to manage the session with me. Thank you very much. And thank you to all, and have a good tea break, and see you to the next presentation, next session. Thank you very much.